Hello everyone, my name is Anna. Welcome back Health Fitness 1047. I wish you a nice day. Here is main news. Let's see then.
The Mesozoic era, spanning an astonishing 186 million years, witnessed the rise and reign of the dinosaurs, creatures that would shape the course of life on Earth. This era unfolds in three remarkable periods. The Triassic, where dinosaurs first appeared and began their climb to prominence. The Jurassic, marked by their explosive diversification into giants. And the Cretaceous, a time of evolutionary innovation before the sudden, dramatic end of dinosaur dominance. Each chapter reveals a fascinating transformation.
Dinosaurs' domination of the Mesozoic era, a 186 million year journey to rule the Earth. During the 186 million years of the Mesozoic era, dinosaurs built a powerful empire unprecedented in the history of life. This journey of domination can be divided into three prominent chapters, each associated with distinctive geological and biological evolution. The first chapter opens in the Triassic period, 252 to 201 million years ago, when the supercontinent Pangaea was still a unified block. In vast deserts under harsh heat, pioneering dinosaurs such as Allosaurus, a 3 to 4 meter long predator with sharp claws, began to challenge the dominance of crocodile-like reptiles. At the same time, Plesiosaurus with its long, flexible neck opened up a new evolutionary direction for plant-eating dinosaurs. Fossil footprints in Germany suggest that they may have lived in herds, a smart survival strategy. The Jurassic period, 201 to 145 million years ago, saw an unprecedented explosion of biodiversity. Pangaea began to break apart, creating warm inland seas and lush forests of giant ferns. In this context, Allosaurus, the lion of the Jurassic, with a length of 9 meters, became the most fearsome killer, while Brachiosaurus with a height of 15 meters stretched its neck to the treetops to feed. In particular, the perfectly preserved Archaeopteryx fossil in Germany revealed an important link in the evolution from dinosaurs to birds, with the first feathers appearing. The Cretaceous period, 145 to 66 million years ago, marked the peak of dinosaur dominance. The continents continued to drift, creating unique ecosystems in each region. Tyrannosaurus rex in North America developed eyesight 13 times that of humans and a very sensitive sense of smell, becoming the most fearsome predator of all time. Meanwhile, the Spinosaurus in North Africa evolved into a unique semi-aquatic form with a crocodile-like snout. The appearance of flowering plants and bees created a complex ecosystem where Triceratops with 3 sharp horns regularly confronted predators. The giant fossil mines in Alberta, Canada, with thousands of skeletons or intact egg nests found in Mongolia have painted a vivid picture of the dinosaur world at its peak. However, it all ended abruptly 66 million years ago by the Chicxulub Meteorite disaster, leaving us with big questions. If there had not been that extinction event, would T-Rex have continued to evolve into an intelligent species? And why did plant-eating dinosaurs always reach a giant size than predators? These mysteries continue to challenge paleontologists today.
Carnivorous dinosaurs were among the fiercest predators to ever walk the Earth. The Tyrannosaurus rex, famous for its bone-crushing bite, hunted alone, using its sheer power to break apart even large prey. Spinosaurus, armed with crocodile-like jaws and massive claws, specialized in fishing, stalking rivers, and swamps for aquatic prey. Velociraptors, small but deadly, hunted in coordinated packs, striking quickly with sickle-shaped claws. Each dinosaur developed unique tactics, making them unstoppable hunters that ruled their prehistoric world. Carnivorous dinosaurs were among the fiercest predators to ever walk the earth. The Tyrannosaurus rex, famous for its bone-crushing bite, hunted alone, using its sheer power to break apart even large prey. Spinosaurus, armed with crocodile-like jaws and massive claws, specialized in fishing, stalking rivers, and swamps for aquatic prey. Velociraptors, small but deadly, hunted in coordinated packs, striking quickly with sickle-shaped claws. Each dinosaur developed unique tactics, making them unstoppable hunters that ruled their prehistoric world.
The giant reptile empire, the most diverse rulers of the age of dinosaurs. While dinosaurs ruled the land, the Mesozoic also saw the dominance of an incredible ecosystem of giant reptiles, perfectly adapted to every environment from the deep ocean to the vast sky. Under the deep blue waters of the ancient ocean, giant sea monsters such as Mosasaurus and Plesiosaurus reigned. Mosasaurus, a sea killer up to 18 meters long with sharp teeth and a terrifying bite force of 16 tons, often hunted large prey such as ancient sharks or even its own species Plesiosaurus. Meanwhile, Plesiosaurus, with its long neck of 72 vertebrae, a record in the animal world, moved gracefully underwater like a ballet dancer, using 4 giant flippers to fly through the clear water. The Mesozoic sky belonged to the pterosaurs, the first natural aircraft of Earth. Pteranodon with a 7-meter wingspan could soar hundreds of kilometers without flapping its wings, while Quetzalcoatlus, a giant with a wingspan of up to 12 meters, as tall as a giraffe, even hunted small dinosaurs on the ground with its 2-meter-long, razor-sharp beak. What's special is that these pterosaurs were not true dinosaurs, but belonged to a separate evolutionary branch of flying reptiles. On land, the dominance did not belong only to dinosaurs. Deinosuchus, a giant crocodile 10 to 12 meters long with teeth the size of bananas, often stalked its prey, dinosaurs drinking from the river. With a bite force of up to 23 tons, twice that of T-Rex, they could crush any prey that dared to come close. Fossilized tooth marks on dinosaur bones in Montana have proven this terrifying hunting ability. Compared to the modern world, these creatures were truly giant versions of today's species. A Mosasaurus could be 3 times longer than the largest killer whale, while a Quetzalcoatlus was half the size of a Cessna. Deinosuchus even makes modern saltwater crocodiles look like tiny lizards. Recent fossil discoveries continue to shed light on this amazing world, from the 13-meter Mosasaurus hoffmanni specimen in the Netherlands, to the giant Quetzalcoatlus footprints in Arizona, to the 2-ton Deinosuchus skull in Alabama. All tell the story of an era when reptiles dominated every corner of the earth, creating the most diverse and complex ecosystems in the history of life. Cause of extinction, double catastrophe. About 66 million years ago, a global biological catastrophe struck Earth, wiping out nearly 75% of all living species, including all non-avian dinosaurs, who had ruled the planet for tens of millions of years. It was one of the largest mass extinctions in geological history. For decades, scientists have debated the cause of this apocalyptic event. Was it a giant meteor from space, or was it a fury from underground, such as volcanic eruptions that lasted hundreds of thousands of years? Today, the answer seems clearer. The end Cretaceous extinction was the result of a double catastrophe, where the meteor and the volcano simultaneously created a chain reaction that pushed the entire Earth's ecosystem to the brink of collapse. It all started with a giant asteroid, about 10 to 15 kilometers in diameter, hurtling toward the planet at a speed of approximately 20 to 25 kilometers per second. The impact site was in what is now Mexico's Yucatan Peninsula. The energy released by the impact was equivalent to billions of atomic bombs, creating a crater more than 180 kilometers wide, known as the Chicxulub crater. The force of the impact vaporized rocks and seawater instantly, creating tsunamis up to 1.5 kilometers high, sweeping coastal areas across the globe. However, the most devastating thing was not what happened in the first few minutes, but the chain reaction that lasted for many years. When the asteroid hit, a huge amount of fine dust, ash and sulfur gas from the Earth's crust was vaporized and launched into the stratosphere. These dust particles quickly formed a thick layer, covering the atmosphere and blocking sunlight, severely disrupting the photosynthesis of plants on a global scale. As a result, an asteroid winter began. The average temperature of the Earth dropped by 20 degrees Celsius in a short time, causing the climate to suddenly turn cold and dry. Not stopping there, the rapid change in environmental conditions also led to the phenomenon of acid rain, when sulfur gases reacted with water vapor in the air, falling to the ground and polluting the entire freshwater and marine ecosystem. At the same time, large-scale forest fires occurred when the heat from the collision was enough to burn forests over thousands of square kilometers. The black smoke from the fires continued to amplify the phenomenon of blocking the sun, pushing living things into a vicious cycle of destruction. However, the Chicxulub meteorite was not the only killer in this tragedy. Before the impact, Earth was already facing another simmering threat from deep within, the activity of one of the largest volcanic systems on record, the Deccan Traps, located in what is now western India. In the million years before and after the impact, the Deccan Traps experienced violent eruptions that released more than 1.5 million cubic kilometers of basaltic lava, enough to cover the entire landmass of France more than 10 times over. These eruptions not only changed the landscape, but also released huge amounts of greenhouse gases, primarily CO2 and SO2, into the atmosphere. This caused global warming and ocean acidification, which led to a serious decline in marine life, which is extremely sensitive to environmental changes. Some studies have also suggested that the Chicxulub impact itself may have triggered or intensified the Deccan's volcanic activity, creating a chain reaction between the natural disasters falling from the sky and the heat rising from underground. While nature was raging from above and below, other environmental factors also contributed to the ecosystem's collapse. This period saw unusual fluctuations in sea levels, causing coastal habitats, where biodiversity is concentrated, to shrink dramatically. As land plants died from lack of light and cold, the natural food chain began to collapse. Herbivores lost their livelihoods, and carnivores followed. Large creatures, especially non-avian dinosaurs, could not adapt to the rapid pace of environmental change, nor could they reproduce fast enough to recover their numbers. In contrast, only a few highly adaptable species survived the catastrophe. These were small creatures that could hide underground, living on carrion or biological residue, or ectotherms that were less dependent on a stable environment, such as small reptiles, amphibians, deep-sea fish, and some birds, descendants of the dinosaurs. Among these small survivors were our own ancient ancestors. Today, with increasingly clear geological, geochemical and biological evidence, scientists no longer ask the question, did the asteroid or the volcano cause the dinosaur extinction? Instead, the answer is, both, and more. This was not a sudden death from a single impact, but a chain of disasters triggered simultaneously, where each factor, from climate change, acid rain, solar eclipses, ocean acidification, to wildfires and food chain collapse, contributed to the greatest biological tragedy in prehistory. The end Cretaceous extinction event is a painful testament to the fact that no matter how strong an ecosystem is, when attacked from multiple directions at the same time, it can still collapse surprisingly quickly. And it is also a wake-up call for humanity today, that this planet is more fragile than we think, and that the balance of biology, climate and environment cannot be taken for granted. History has witnessed a day when the sky was no longer sunny, the land was no longer green, and the strongest creatures that ever lived were wiped out forever. It is not just an ancient lesson, but a stark reminder for the future. Scientific evidence. In 1980, a seemingly trivial geological discovery opened the door
Powerful
to one of the
volcanic
greatest
eruptions,
mysteries in
combined with
Earth's
the
history.
impact of
Why
a
did
massive
dinosaurs,
asteroid, sent
creatures that have
shockwaves through the
dominated the planet for tens
biosphere,
of
turning a
millions of
vibrant
years,
world
suddenly
into a
become
place of
extinct?
darkness and extinction.
The answer lay in a
Even the
thin layer of
mightiest
soil,
dinosaurs
less
could
than
not
a few
survive such
centimeters thick,
devastation.
deep in ancient
This historic
geological
collapse
layers.
reminds us just how
That layer
interconnected
contained a
and
rare
vulnerable.
element, iridium, a heavy metal of cosmic origin, usually found only in meteorites and asteroids. This discovery not only laid the foundation for the dinosaur-killing meteorite hypothesis, but also began a worldwide hunt for scientific evidence, from the depths of the sea to the dead deserts, to piece together the tragic picture of an apocalypse that happened 66 million years ago. The first iridium layer was discovered in Gubbio, Italy, by father and son scientists Luis and Walter Alvarez. The element's dense presence initially puzzled researchers, because iridium is an extremely rare element in the Earth's crust. It rarely occurs in such high concentrations. But when geologists surveyed dozens of other locations around the planet, they realized something horrifying: the iridium layer was everywhere, from North America, Europe, Asia, all the way to Australia and Antarctica, and always right at the boundary between the Cretaceous and Paleogene periods. This consistency in timing and composition couldn't be a coincidence. A global asteroid impact, large enough to send iridium into the atmosphere and settle across the entire surface of the Earth, was the only plausible explanation. But one big question remained: where did the meteorite fall? It wasn't until 1991, thanks to a combination of seismic technology, satellite data, and sophisticated geological analysis, that the answer emerged. The Chicxulub crater, hidden beneath a thick layer of limestone in Mexico's Yucatan Peninsula. At more than 180 kilometers in diameter and some 20 kilometers deep, it is one of the largest impact craters ever discovered on Earth. Most importantly, the crater's geological age matches almost perfectly with the time of the dinosaur extinction, some 66 million years ago. The geological structure around Chicxulub shows undeniable evidence of a cataclysmic impact: rock melted into glass, quartz crystals shocked, fractured in a way that only occurs under extreme pressure, and sediments filled with molten material. These fragments, after flying into the atmosphere, created a thick layer of dust, causing an asteroid winter effect that collapsed the entire food chain on the planet. The Earth was hit, and the impact was so strong that it left scars that are still visible tens of millions of years later. However, if the iridium layers and the Chicxulub crater are evidence of the impact from the sky, paleontologists also found vivid biological evidence of its consequences, right under their feet. One of the most important sites is the Hell Creek Formation, located in the state of Montana, USA. This is not only a rich fossil land, but also a giant graveyard of the Cretaceous period. Here, scientists discovered a sediment layer containing a series of fossils of dinosaurs, fish, reptiles, plants, and microorganisms, all died at the same time, and lay right under the soil layer containing iridium. Many of the fossils at Hell Creek show that they were buried suddenly, perhaps by mudslides or hot ash that covered them in an instant. Some samples also contain tiny pieces of glass, a clear sign of a meteorite impact. Even pollen and bacteria in the surrounding sediments record a sudden change in the ecosystem. Plants died off en masse, marine life became impoverished, and large animals disappeared without a trace. All of these data, from iridium, to Chicxulub, to Hell Creek, combined to form an unassailable scientific verdict. A giant asteroid crashed into Earth, triggering a catastrophic biological and climatic chain reaction that led to the extinction of most living things, including all non-avian dinosaurs. What's remarkable is that this evidence not only confirms an event that happened in the distant past, but also serves as a warning for the present. The Chicxulub asteroid may have killed the dinosaurs, but it also revealed a simple, cold truth: Earth can change radically in an instant. And it could happen again, if we're not careful, or if humanity continues to mess with the climate and environment to the point of creating its own catastrophe.